So you just accept that recording permission. So everyone has opened AxCYCLE. Can anyone please reply to me? So I'll move to the next thing. Abhishek sir. Am I audible or not? Should I start? Should I go ahead? Everyone has find AxCYCLE. They are. Have you got AxCYCLE? You can reply in chat box. So now, anyway, I will start the presentation. You can, if for example, if you miss something, you can do that afterwards. No problem. So what I'll do, I'll give you first one small presentation, very small, so you'll get the idea. So basically, AxCYCLE is a thermodynamic cycle simulation software. So here we design the system thermodynamically. So basically, whatever the steam cycles. Yes, Prash sir. So AxCYCLE is basically a thermodynamic cycle design and simulation. So thermodynamics हो गया, refrigeration हो गया, power plant हो गया, this type of cycles we can model in the simulation software. Basically, we are doing heat balance calculation here in virtual environment. So basically, we use the thermodynamics parameters like pressure, enthalpy, fluid quality, temperatures. Okay, we don't require a mechanical geometry here because we are simulating a cycle thermodynamic way, which we generally do in the academics. Okay, and like calculating the results and plotting the pH and TS diagrams. So all those things we can do in the AxCYCLE. So which type of cycle, like steam, gas, combine, or organic cycle, okay, heat pumps, refrigeration cycles. So we'll see 2-3 cycles for today's session, like steam and gas we'll see, as well as one refrigeration area. So these are the larger one cycles, and their graphs and images has been shown, like fossil, supercritical, okay, combine. Okay, so we'll not go in that much depth. We'll see a simple cycles which are very easy to understand and very easily we can model. Basically, my name is Suraj Vaishnav. I forgot to tell everyone, my name is Suraj Vaishnav, and I had given you the presentation on the witness. Basically, I am not an expert in the thermal domain. Right now, our engineer has been infected with the COVID, so he's in the hospital, and right now he's safe. But I know the software. I'm not expert in that thermal domain, but I know the software, how to use that, and you are very much aware of all the thermal things. So you'll easily able to get that, and you have a much more knowledge than me to understand in the as per the domain wise. I can tell you what is the software and where are the things and how to connect and do the things. So that thing I can do. So everyone, just open the AxCYCLE. As I said, AxCYCLE, it is visible here. So here you can see AxCYCLE. Now here we have various elements, various components, I can say, to model the cycle. Like in turbo machinery, like turbines, compressors. pumps. If you go in the gas turbine engine, so gas turbine related GT engines, directly engines are available, total detail type. So engine libraries, so you will have a various engine with their libraries. Okay, you can select their OEMs like Hitachi, Kawasaki, and all those engines with their parameters are available. Okay, so this is engine library. Okay, and then heat exchanger, like you will have a condenser, then you will have a boiler, then you will have a evaporator. So these elements we'll see one by one. Some of the elements. Maybe burner, you will have a for gas turbine sections, you may require a burner, so those are also available. Then these are the auxiliary types of component like separator, mixtures, okay, splitters. So these are also very much important. Okay, valves, then generator related elements, these are available, and there's some auxiliary for the other purposes. So now how we have to start, like for example, I'm going to build a simple steam cycle. Which type of steam cycle? Let me open that steam cycle with me. For example, I have some cycles with me. Okay, so I'll open a small steam cycle which we are going to see. For example, it's a one steam cycle. You can see here we have a boiler. Okay, so then its steam goes to the turbine, then via condenser and feed pump, it again fluid goes to the boiler. So this is a simple, very simple steam cycle. Generally we teach in the academics. So this cycle we are going to build now today for today purpose. So everyone, please follow my step. Okay, I'm closing this. I can click on the new. Here is a new option. You can see new. This will not save. I say okay. So it's a fresh I got now. Fresh element, fresh window I got now. Okay. So here is the new options I have used. Now for build, as whatever I had shown, what you have to do, you have to drag and drop this element, this type of element. So this type of element we have to drag and drop. This is the boiler. It's nothing but a type of a heat exchanger, the turbine, then generator, condenser, and feed water pump. So for example, I'll go and I'll add each and every element one by one. So for example, I want to add turbine. Go to the turbo machinery, add a turbine here. First element. Okay, everyone please add a turbine from the turbo machinery, the first element. You can see, you can go there, turbine with the options has been given. Okay, go to the turbine, add it. After turbine, for example, I go my relevant element, then I will require a boiler. So you just go to this boiler library. You can expand this, okay, like this. You can see it expands as per your convenience. You can zoom this, like you click here, press on a, you can expand this, okay, as well as zoom in, zoom out by pressing a control button, and you can move your cursor center button. Okay, you can rotate that and zoom in, zoom out easily like Windows function. So turbine I got in the system. Now I go to the heat exchanger. I'll require a boiler. So I got a boiler. This boiler, please see this boiler. This boiler. Okay, this boiler. The color you can see here. Okay, this boiler. This boiler you just take. After taking a boiler, you just take a condenser. The first one, the first element which is here at the top, you take a condenser. So condenser we got here. I put it here. Okay, like this we have to create. So turbine you select a condenser. Condenser is the first one. Everyone is done that till this point. Then turbo machinery. In turbo machinery, you have to select a feed water pump. The first pump you can see, pump with a mechanical drive. So here you select a feed water pump. So feed water pump is also selected. Everyone select feed water pump in the turbo machinery area, the first pump. And we require a generator for this area. So go to the generators and motor, and this is how we select drop a generator options here. Just first generator, you can see the first generator and motors area, the generator you have to add. I'll repeat again. I'll again show all the elements. So simply you will get able to get idea. In turbo machinery, take a first turbine, and at the bottom there is a feed water pump in turbo machinery area. You go to the heat exchanger library, take a first element as a condenser, and the boiler, it is available here. Boiler with efficiency. So this is a boiler. Then for getting a generator, you have a separate tab of a generator. So drop the generator here. Everything you can arrange that, you can move anywhere you want. Okay, same like a witness and all those things we had seen, na? Same time. I think most of you were there at the time of a witness simulation software. Then I'll start the connection. Now just see the connection. Okay. Just see the connection. Here, from boiler, you can see outlet of the boiler goes to the turbine. So I have to just click here and drop that click. You have to click here and come the next click to the next area. So you have to be in the click mode. Click and take it to the this point. Okay. Click by clicking. Keep your mouse button clicked and come to this port. Now this will send to the next. Click here, bottom. You can see the connection. Okay, please observe the connection. Yes, Prayas sir. हाँ, कर दिए मैंने, एडमिट किया है. ऑटो एडमिट है मेरे इस पे, ऑटोमेटिक एडमिट हो जाता है. एक मिनट. Somebody wants to join, so we'll wait for half a minute. So I hope everyone is in now. Abhishek sir, have you done this? We have to drop these elements and connect. If I am not audible, please inform me. I hope I am audible now. Everyone done that model? Please reply someone. Yes, okay, very good. Thank you very much. Now, now I'm going to add the parameters for this. For example, some given values has been given. Those values I am going to put now. So you just follow me. Okay, you just follow me given values. First of all, if I click on a turbine, I have to select a turbine. If I select a turbine, just expand this window. Okay, in the right hand side, just expand this window and select a turbine. Select a turbine. For example, in the turbine, there are some requirements. What is the internal efficiency? Okay, so what is the internal efficiency related to turbine? And you just keep it at 0.9 only. Okay, So internal, these are the given values we are just putting right now. So internal efficiency, keep it 0.9 only. Here, fluid media, keep it steam, because on turbine, steam is going to come. So basically, keep that steam, because it is a closed loop cycle. So automatically you will able to, we don't have to put a fluid everywhere. So at only one place we can specify in the fluid media, select a steam. Okay. So you, after clicking, internal efficiency 0.9. Okay, now some of the some mandatory values are also there with other components. These were related to a turbine only. If you go to the condenser, you will have here a pressure loss option. So keep it as zero only right now. Okay, by default, whatever it is, keep it as zero. If you click on a condenser, keep it as it is. If you, for example, if you go to the pump, and in the pump, it will ask for the internal efficiency. So for example, you can keep that 0.75 or 0.8, whatever as per your requirement. Okay, these are some given default values has been given, those we are putting. You can go to the boiler similarly, and pressure loss you can keep as it is. Okay, and you keep the efficiency right now. But hypothetically we are doing the model right now. Okay, so keep it as one means 100 only, and pressure loss 0. You can change as per your requirement. Right now, hypothetically, I'm building the model, so you will get the idea how to build model and which are the things we can specify here. So this is how the model goes. These were all the properties were initial properties only. We haven't fixed anything. These are the some basic given properties which are required. Now the actual problem statements start right now. Okay. So constraint value now is going to start. So the constraint value will be, if you go to the turbine, now I'm going to see a constraint. I'm going to put a constraint value. Okay, I'm going to put a constraint value. If you go select a turbine, go, and here you can see this is the link one. You can see link one. Somebody might have got link 2, link 3, link 4. Let it be whatever the name of the link. Let it be. Okay, I got a link 1 because first connection I had done like this, so that's why link 1 it is saying. If I go and click on a turbine, I have to select turbine, link 1, you can see here is an inlet link 1, because this is the inlet for the turbine, and link 2 is the outlet. Can you see? So basically we can see here it is an inlet link 1 and outlet link 2. Okay, so at inlet link 1, the mass flow rate you can see here. Here you if you click, we are going to specify a mass flow rate here in this problem statement. A fixed value of a mass flow rate we are going to take. So here you can see is CALC. CALC means calculated value. If you click on a CALC, it will ask fixed value, initial value, calculated value. So fixed value is basically you want to put a constraint, so it comes as a fixed value. Calc value means the software will calculate that value, and initial means initial assumptions. Some of the assumptions we are doing, that's called an initial value. So I say fixed, and in the fixed I put 100. Here you can see mass flow rate. I am going to put 100 kilogram per second. Okay, mass flow rate. Then fixed, we are also fixing the pressure. So pressure inlet. Okay, inlet, the pressure which is coming on the turbine, that I am putting here 100 again. Okay, I want to put 100. Now we are also fixing the temperature. For example, we are also fixing the temperature, and I say 600, for example, 600 degrees Celsius. That is also fixed. Okay, now for example, I say software to calculate the value, it will turn into red. Don't calculate right now. Don't calculate right now. It will turn into red. If I go here in the log, calculation log, unsuccessful completion, the basic what it say, 4 fixed conditions should be defined, 3 have been actually defined. So total 4 fixed constraints we have to define at least, but we are able to define only. If I go to the turbine, you can see here you have to put this 3 value. Please everyone put this 3 value. 3 values only have been defined. Now I am going to add a 4th value also, where in the output link 2, here this one, somebody might have got output link 3 or something. Let it be output link 2. These are the inlet value. The steam which is of 100 mass, you can see here, with the pressure, with the temperature, is coming on the turbine at the inlet side. Now at the outlet side, for example, I keep pressure fixed. I'll keep a pressure at an outlet side, for example, 0.5. I keep it as a 0.5. Okay, so 0.5 pressure I have kept. Now, all the four major value we have given, whatever we required as per the boundary condition which was said, four values has been incorporated in the software. Now, but I calculate that it will still say some errors. It will say some initial properties has been left. Like initial properties, I'm going to tell you which we can put here. Okay, so if we put this any one two three initial properties, it will turn into green, it will solve again. But some initial properties which I know, I will tell you which we can specify. Okay, for example, you go to the condenser, click on a condenser. After condensing, the fluid quantity will be fluid will be a water. Okay, so after condenser, so condenser outlet link 3, you can see here, condenser outlet link, fluid quality, keep this as a initial, initial 0. Keep this value as initial. 0 means water. Okay, as it goes in the steam area, 0 to 1 we generally the way it is taken in the software, 0 to 1, this is a 0 water, 1 it goes to the actual steam. Okay, so keep this as a fluid quality here in the condenser outlet link as a 0, as a 0. I hope I am audible to you. I am audible to everyone. Sir, everyone is following me? Everyone has done that, whatever thing I have done? Somebody please reply. Somebody please reply. I hope everyone has done till that point. Yes, carry on. Good, thank you. Like you might face a problem of internet connection from my side, because of a heavy rain, there is a lot of power shortage and maintenance work is going on. So you might there might be some interruption for some seconds or some minute. Okay, because we have a backup, but it takes time to get activate. So there might be some connection problem. So in a minute or something, it will be restored. If you face any problem, you can directly call me if I'm not audible or something, or I left from the meeting. Then I go to the next thing. As I said, I have to specify the initial condition. So for example, I go to the generator, and generator electrical power output. For example, you go to the generator and electrical power output as an initial quantity and write. So basically we are extracting, that's why we have taken a minus. Okay, so minus 100 is the power we are extracting. Initial value, it is not a fixed value, it is an initial assumption. Software will calculate it automatically what is the final value as per the boundary condition which we had already, 4 boundary condition we had specified. Okay, so then again here again, for example, if you go to the pump, and at a pump, now till now you have done the initial value of this area, generator is done. Then I at a pump, I have all the notes related to this problem statement. After the session over, I'll make it a complete tutorial type guide, something on the and I'll send you the PDF file, so you will better get idea very easily, and very easily able to solve this problem statement. Okay, then after that, go to the pump, you click on the pump, and pump output temperature. For example, pump output temperature, pump link number 4 is the output for me. Okay, here is the liquid outlet link, output temperature, pump, make it the initial. For example, I say 50. I'm going to get a 50 initial assumptions. You can write 60, 70, 80, 100, 90, whatever assumptions, what do you want to specify. Then again, at a turbine, come to the turbine, outlet link. You can see here is the outlet link, output temperature. Again, I say initially a turbine related outlet, for example, 50. I'm again saying a 50 here. Assumptions, I'm doing assumptions. Okay. and and you can do you can go to the condenser now. Condenser, okay, turbine output temperature initial quantity, okay. I go to the condenser outlet temperature, condenser outlet temperature is initial. Again I say 25 here. You can see outlet link. So condenser output is also initial value 25. Okay, condenser initial value 25. Like now I'm going to see calculate. So the software, some error has been given. Let me see what is that error. Let me see what is that error. Let me see. Just a second. Just a second. Don't calculate from your side. Just a second. Just a second. Let me see what are the things which I have. So if something, any property I have uh, done by mistake or something, that let me see. Okay. Let me see. Some initial condition, fluid outlet quality is done. Turbine outlet pressure is also done. Okay, boundary condition done. Okay, pump internal efficiency is also taken as 0.75. Yes. Okay, so it is saying condenser 1, it is giving error for me. Enthalpy, entropy, temperature, void function, and internal energy for component condenser 1 in a link 3 is assigned more than once. In link 3, assigned more than once. In link 3, assigned more than once. Assigned more than, yeah, sorry. Okay. So condenser, here the condenser output which was given, na, condenser output temperature, I think condenser output temperature, this is the condenser link 3 temperature which was here. Just make it this temperature as a calculative value. Now everyone should get this calculate. Everyone should get, because we generally get errors immediately. So this turn into green means is solving is done. So can anyone just tell me everyone got this? Otherwise, what I'll do, I'll revise everything. Okay, I'll revise a smaller one very easily. Everything I'll revise everything. So in a one model, you will able to understand what is the software is doing. So basically, I go here a turbine. So you just see, I'll clean calculation. For example, there is an option of a clean calc data. So you can clean your calculations and we will revise everything. Okay. Cleans means calculation has been, we will calculate again. So if you go on the turbine, just observe these are the things you have filled. Expand it. Internal efficiency 0.9 I have taken. This is a fixed quantity. Okay. Fluid media, I have selected a steam. Fluid media I have selected only once. You have to specify your steam. Then you go here, pressure 0.5 fixed. Okay. Outlet side. A temperature at the initial level, it has been specified as a 81. You can write down 50, for example. As I said, it's an initial value. 81 has been calculated by software. What was the problem occurred? The temperature was here, whatever the temperature was here, and this temperature I specified 2 times. It was not required because same temperature goes on. So it was not required 2 times. So that's why the calculation was not going, was not solving. So 50 you're done. Now I move to the generator. Generator, you just had write down here, for example, 10,000, okay, minus 1,000, 10,000, anything, initial value. That's why you can write down anything. You go to the condenser now. Condenser now, everything is same. Just make this initial value fluid quality 0. So water output will be a water type. So that's why fluid quality 0. Go to the pump, everything is same, just make this internal efficiency 0.75 and temperature at the outlet temperature after the pumping is done is 82. Okay, initial value. Go to the boiler. So in the boiler, you write down this pressure law 0, efficiency as a 1, and heat inlet 1000 you can write down. Heat inlet 1000. If everyone done this, then click on calculate. So it will turn into green, means it's calculated. So I hope everyone has done the calculation. Okay, everyone got green button. Everyone got green. Most of you might have got green. Somebody you haven't got, please cross check your model with your colleagues. Okay, if somebody you haven't got, as well as after the video is uploaded, you can try that. Can somebody reply? Okay, yeah, Veer Singh sir, I hope you got this. Yeah, thank you. Then after that the calculation has been done. Now I go to the calculations. For example, here you have options of results. Go to the results. So at each and every stage, what are the calculation we are getting? Okay, you move to the cycle again. Move to the cycle. Like for example, if you click on the generator, now previously you are given something 1000, and now you got this much power, because as per the boundary condition you had given, all the values has been calculated. If you go on the turbine, each and every value you will be able to see. Now all the values has been calculated. What is the enthalpy, what is the actual fluid quality, what is the entropy, everything has been calculated in this area. If you go to the condenser, everything has been calculated, input as well as output. So every value has been given here. So the software has calculated rest of the thing. So what is the actual overall efficiency, everything you will able to see. Go to the results area, you will able to see the results in this area. Okay, in this results, basically you will get this at input and output areas. What are the results? What is the pressure? What is the enthalpy? What is the temperature? And if you go to the report area, you will have a detailed report. You can export that into Excel also. Here is the option of export to XML. So turbine with optional. Okay, so these are the blue and the red one are the fixed values which we had done. Overall, all the values and the results has been given in this. Okay, has been given. This is the cycle data. Most important at the bottom, the cycle data. Here you can see these are all the details. The thermal efficiency of the cycle is what? This much. So these are all the details at the bottom side has been given. Cycle data. I hope everyone got this. Now some of the things we are going to try in this model. You can click on the process. Go to the process. So pH and TS diagram we will able to see here. pH and TS diagram. Go to the process. Here is the option of auto process steam. If you click on auto process steam, this is the TS diagram. I have selected a TS, you can see here. So auto process steam, you got a TS diagram in this area. Okay, so basically you can see this is a boiling, then superheated area, then turbine area, then again that goes to the condenser and from feed water, the boiling area. This is in the region of this saturation area. Okay, then mixed area. Then this is basically your chart. Similarly, you get a pH chart. So this is the pH chart. So pH chart is also able to get it. Okay, everyone is getting this. I hope so. You can save this process also. Okay, you can take a printout, screenshot. Okay, whatever you require, you can, like for example, you can specify problem statement. They will solve this, and you will get the pH chart related to that. If you click on the process, you will get this. Now there is an option of map. Can you see here map? In the map, basically what we do, we try to do some iterations, some experimentation we are able to do here. In the map, for example, the given problem, mass flow rate, I have selected 100. If this mass flow rate changes, what will be the effect on the rest of the parameters? For example, I want to see here. I go to the mass, I select a turbine, and here I select a mass flow rate. For example, from 80 to 120. this mass flow rate changes in the step of 10. For example, 80, step of 10 means 90, 100, 110, and 120. How it affects on my cycle data, rest of the cycle data. I want to see how its effects on my thermal efficiency, for example, and my electrical power production. Okay, so these things I want to see. So here basically we can select two variables. This is only mass flow rate. You can select internal efficiency, or you can vary anything. Two variable you can select. Okay, variable 1, variable 2. With respect to two variable, what are the results we are able to get? So I selected 80 to 120. I click on calc map. So software will calculate. If 80, your efficiency will be this. If 90, your efficiency will be this. Okay, and what is the electrical power production? What is the electrical power production? Their charts you want to see here. For example, I say on the x-axis, I say mass flow rate. On the y-axis, I say electrical power production. I say apply. I can go into the, here is the option of a chart. You can see. I click on apply. Software will calculate that. Okay. So this chart is also available. So simply we get this in the map. Similarly, in the case, now here options of two variables. For example, in the case, you can specify as many as variable. 1, 2, 3. 3 variables are specified, for example. So all three things I'm going to change, and how it affects on my thermal efficiency or electrical power production. Okay, and in how many cases I want? For example, I say 3 cases I want. So 3 cases I want, and I click on adjust parameters. So I can specify different cases. So turbine mass flow rate, for example, here 100. Here I'll say 110. Here I'll say 120. A pressure, for example, I say here 90. Here 100. Here 110. Temperature, here I say 500. Here I say 600. Here I say 700. Any value you can take. Okay, and I say calculate case. So you will get the values related to that. Okay. Electrical power production, what we are getting. So that is, those are values we easily able to get back. Thermal efficiency. Yeah, this one is the thermal efficiency. And I say calculate, adjust parameters. Thermal efficiency, calculate case. So this is how it is calculating. So you get all the values. Similarly, chart like previous one only, you can specify your chart. Okay, you can send it to Excel. For example, you want to send these results to Excel. So send to Excel. If you click directly in the Excel, it is plotted very easily. No need to do anything. You get the results directly here. Okay, so very easily you will be able to plot the in the Excel. So everyone done this model. Should I move to the next model? In a shorter time, we'll see the next model. This one was in the detail one which I wanted to show. Now in a very shorter time, I'll be able to show you a next one. Okay, should I move ahead? Press, sir. In how much time should I complete this? So according to that, I will decide whether I have to take one model or 2 models. One model or 2. You can save this. You can click on a save. For example, in desktop, you can write down whatever name, like steam cycle, for example. You just write down a steam. Okay, and you can save this in the steam format. Steam option will be given there. It's very easy. Now I will directly, instead of going to the thermal power plant cycles, I'll move to the refrigeration cycle. Okay, so you will get something different here in the refrigeration area. Okay, yes, thank you, Veer Singh sir, for replying. Now you can click on a save. I hope everyone has saved this model. You click on a new, for example, if you save, click it is saved, then click on new and say okay. So fresh window you will able to get. Now in the refrigeration area, you have to take basically elements. Now you will require a compressor first. Okay, compressor. So go to this area and turbo machinery area. Here is the compressor which is available. The third last button, you add a compressor here. Add a compressor here. Add a compressor here. Compressor added from my side. Okay, I have added compressor. Now you go and go to the heat exchanger library. Heat exchanger library. Add a condenser. Condenser. After compressor, the process is condensation only. Correct? So refrigeration में ऐसे है ना, compressor, then condenser, then expansion, and after that evaporation. I hope so. I hope I am correct. Correct? Then go to the expansion wall. In heat exchanger only, we will get a evaporator. So here you can see this one. Please take this one as a evaporator. This one as a evaporator. Okay. Now you just revolve this. How to revolve this? Here you just observe. Everyone just observe. Don't follow. Don't repeat it. Just observe. I have to click. I can click here and I can revolve it like this. Okay. I have to click on that window on this yellow button. After selecting this model, I can revolve it like this. I can just click on that button and drop it in that area. Drop it in that area. Like just simple refrigeration cycle, you'll able to see. Just a second. It should look like this. It should look like this. The three that heat exchanger, removing arrows. Yeah, here is you can see. So you have to, what you have to do, you have to click on this yellow arrow. It is here. You have to just drop it like this. Now expansion valve is left. Okay, we have done with that. Now go to the valves, and here is the expansion valve. First one in valves, expansion valve, and you can also revolve it like this. Here, like this. I'll repeat. Please observe. Click on yellow button. Revolve it top side. All the elements has been added in the or area. Go here. Now, what you have to do? This outlet goes to the top side. Please click on the top side. Okay. Don't connect here. Outlet goes to the top side. This outlet goes to the top side. This bottom one goes to this bottom side. This one comes to this side, and this one come to this side. Okay, just make it sure this is not connected here, the compressor outlet, and rest of the connection will be automatically connected very easily. Only we have to observe this connection. Okay, this one. It's a drain inlet, so we should not connect this right now here. Everyone is connected. I hope everyone has connected all the elements. Now it's very easy. Okay, I'll repeat. Okay, thank you for the information provided. I'll repeat all the elements. Okay, I'll repeat all the elements very easily. Compressor is in the turbo machinery library. Drop it here. Compressor, keep it as it is. Go to the heat exchanger, and first one is a condenser. Keep it top. And second one is the evaporator. Here you can see it is also heat exchanger. Keep it at the bottom. You can revolve it by control. Nothing has to be pressed. Only click on your mouse and drop it like top side, the yellow button. It will automatically revolve. So it should look like this. The three heat diffusion arrows should be look like this. After that, go to the wall. Wall is available in the wall area. Wall is where walls and seals. So the first one, take it as a wall. Similarly to this, you have to click on the yellow and drop it like this. So it should come as a vertical. Now, please make sure this connection has to be made with the top one. You have to click here. Otherwise, what you just do from top side, come to this turbine side. From top side here, come to this turbine. You can delete this by selecting this and pressing a delete button. Okay, pressing a delete button or computer's delete button. Next, this take here. This connect here. This connect here. Or I will make it simpler. I will disconnect all these things. So our connections will be very much feasible. Nomenclatures will be very much easier. I'll connect the first connection this. Okay. Now this output, the second connection, I'm like doing this. So you'll get a nomenclature. 1, 2, third connection I'm getting like this. Fourth I'm doing here. So you'll get a very good nomenclature. Very good nomenclature. So 4, and very easily we will able to solve that very easily. there is options of a reference component. Okay, if you go to the auxiliary section, for example, go to the auxiliary section, and if you add a reference, add a reference and drop one arrow from to this reference, from one point to this reference, you can add as many as reference you want. This reference I have added, and I want output result of the condenser. So their basic properties will be visible in the reference point. As many as you can add. One thing I just want to show you here is you can set the units. Just everyone please go to the options, go to the option. In set units, use this pressure as a kilopascal. Pressure, make it a kilopascal. Pressure, make it a kilopascal, and say okay. You can specify all the units as per your requirement. Now I just want to show something. There are options of adding the custom fluids. Okay, set custom fluids. So you have options to make any fluid. For example, I want to do flue gases. So flue gases for gas turbine. What should be the combination of my flue gases? I say oxygen, I say nitrogen, I say carbon dioxide, I say I say water. Okay, I say H2O. Where is H2O? Yeah. So I can specify their molar fractions. So 0.3 percentage, 0.2 percentage, their molar 0.2. Okay, 0.3, 0.2. Okay, so this is how, and I can save this. I can add a new fluid depending on my requirement. I'm not going to save this right now. I just wanted to show you. Okay, so your set units, pressure, kPa, take it as a kPa, kilopascal. Rest of the thing keep as it is. Everyone order this, all the elements. Yeah, kindly, nothing is there. Thank you. Now I'm going to do property addition now. Okay, compressor, go to the compressor, go to the compressor, go to the compressor. Some mandatory things like you can internal efficiency, you can specify. For example, I will specify 0.8, I will specify 0.9. You can keep it 100% something depending on your problem statement or assumptions. Okay, these are the mandatory things which we basically have to give. Okay, mandatory things basically we have to give. Now come to the fluid media, which is very much important. Come to the fluid area. In the compressor area, fluid. Here, fluid in the library, say select a cool prop and R12. Cool prop R12. Cool prop, you go to the cool prop and select here R12. So R12 refrigerant I'm taking here. Okay, R12 refrigerant. So you just observe this internal efficiency, mechanical efficiency. Everyone got this. Now at a compressor only, at a outlet, this outlet is a link 1. You can see outlet link 1. My link 1. Okay, whatever your just see there outlet, this is the my link 1 outlet. I'll make a in an outlet I want a compressor pressure, a compressor pressure fixed as a 16 kPa. 16 I'm writing down. Okay, 16 I'm writing down. And at the inlet, this is a link 4. At the inlet link 4, I'm keeping, for example, mass flow rate as an initial value. Mass flow rate, for example, 0.05 kilogram per second initial. Okay, at the inlet link, please see here on the compressor inlet link of 0.05 kilogram per second is the mass flow rate of the fluid, and outlet is the fixed quantity of the pressure I'm getting that. Okay, so mass flow rate you have to specify it only once, and pressure I'm getting this much. As well as at an outlet, here you can specify, for example, enthalpy, something. Temperature also you can specify enthalpy, but I am selecting right now enthalpy. In the previous model we had done temperature. initial assumptions. For example, after compression, there might be some increase in the temperature. So according to that, you can specify enthalpy, anything, or temperature you can specify. But I am specifying right now enthalpy. Okay, in this model, I am setting enthalpy. And here, as well as initial value, just write down heat loss, for example, -1. Okay, heat loss, you can specify a -1. Heat loss, please specify a -1. Heat loss -1. So compressor related value, everything is done. Only our main boundary condition is a 16, the pressure. Rest of are the initial assumptions. Now go to the condenser. So it's a top link. Okay, top link is the inlet from top side. The link number 1 is the inlet link for the condenser. Okay, condenser. So pressure loss, you can keep it as it is. Pressure loss, keep it as it is. Okay, output, but here was just what you have to make after condensation. This there will be liquid. So link number 2, output link number 2, and fluid quantity initial, you just make it a 0. So it will be a liquid. I'm saying initial property is a 0, liquid. Done. Nothing has to be done now in the compressor, condenser. Now come to the expansion wall. In expansion wall, only one thing you have to change. After doing an expansion, what is the pressure we are getting? That I'll just write down a fixed quantity of a pressure which is going, the pressurized fluid. What is the pressure of the fluid which is going to this evaporator? So that outlet link, you can see link number 3 for me, outlet link, the pressure fixed value is a 3 kPa. Okay, 3 kPa. Done. 3 kPa. Now come to the evaporator. This is very much important because only 2 boundary conditions are specified. For example, I click on a calculate. Don't click from your side. 4 fixed conditions should be specified, but actually 1 has been defined. Okay, so we have not defined rest of the thing yet. This pressure should be fixed. Okay, please make sure that this one, the wall, it has a outlet pressure 3 kilopascal fixed. And if I calculate this, the error I will get here at the bottom, error, 4 fixed conditions will be defined, 2 have been actually defined. Okay, like it is like a problem statement what you give in the classroom. Some of the given condition has to be there, otherwise we assume that, or some of the main given condition has to be there. So 4 fixed conditions should be defined for this problem statement, but we are only able to get right now 2. So the next 4 condition I'm going to tell you. Okay, I'm going to tell you the main. Go to the evaporator. Now it's evaporator very much important. Here we are going to specify 2 fixed conditions. Pressure loss, keep it as it is. Okay. Now go to the outlet temperature, outlet link, temperature, make it fixed. For example, -15, -14 I write down. -14 I write down. Okay, -14 for example. After evaporation is done, the temperature is still -14. Okay, because after expansion we'll get very less temperature, but after getting a heat, still it goes to the -14. But after expansion, I will see. I think we'll get a -50 or something more than that in that area. Now come to the -14. Only one property is left now. Here you just write down heat as a fixed, heat as a 15, because heat addition process is going on here. So that's why we have added output which is coming to the evaporator will be heat addition will be done once the evaporation process is done. Say 15. Everything is done. Now all the properties I hope we have specified, and if I click on the calculate, hopefully it should calculate. Yes, it has calculated. Now the software has calculated all the values. I hope everyone got this. Everyone got this. Should I repeat? Or everyone got this? I will repeat it very faster way if anyone want to repeat that. Very simple two example we have done. Steam and refrigeration. One experiment from the steam area, one refrigeration, one from the refrigeration area. So in the thermodynamic subject also, in the refrigeration subject also, or you can use both of these uh, tutorials, both of these problem statements. Okay, I hope it's okay, sir. No need to repeat. That's very good. Now what is left? Just we want calculation is done. Go to the result sections. In the report you can see here is the options. What is the coefficient of performance, and all those values will be specified here. Okay, so all the things will be visible here. Their results, everything is here. All the things, all the results. I can add a reference point here. So by adding a reference point, you will be able to get results very easily in this area. If I add all the reference point here and there, so you get the details very easily. You can see here. Here also I'll add a reference point. For example, we'll able to get what is the fixed value we had specified. You can change this also, a reference point. What are the reference value wants? So it's calculated. So all the details values you will able to see here. So what is the pressure ratio which can be which is used? Initial mass flow rate we had given something 0.05. Now it's saying 0.07 you should have. But as per the constraint we had defined, as per the constraint which we had defined, it is saying, okay. And depending on that, we get the rest of the calculations very easily. So here is the detailed reports which are available. Details reports which are available, and which already we have seen. You can go to the process sections. In a process sections, you can write down on auto process 12C, for example. So pH and TS diagram you will able to get. This is how TS diagram. Auto process this. So TS, it is in the logarithmic mode. Okay, it is in the logarithmic mode. You can remove the log also from this area. Okay, so this is the actual one, and if I use a log, then it will change the ratios and values here at the bottom also. So in this way it is there. So this is how a refrigeration cycle we have seen. Anyone faced any doubt, questions till now, or if any other one more model I have gas turbine related, if it has to be done, then please inform me. If gas turbine, if you want to done, do. Otherwise, I will directly open and show you what is the gas turbine model. Otherwise, you will get it will require some time. I'll directly show you and I'll send you the models also. Okay, I'll send you the models. For example, I say load. I say load. Here you can see option of a load sample. So in that load sample, you will get a good number of examples. Steam cycles, GT cycles, organic Rankine cycle. Here you can see gas turbine related cycles. Okay, if you go to the steam, there are various numbers of steam cycle. This is a simple one. If I click this, let me see. Yeah, so you see this. We don't even need to do a lot of things. So you will able to get, you just note down what are the initial values and what are the fixed values. Just drag and drop component and calculate that. Here is a clean calculation option is available. So you will able to get that. Load sample. Again, you can see various individual cycles. Steam, it is there. Then after that, simple GT. Here you can see various detailed number of cycles available. Lot of cycle, turbofan, turboprop, organic Rankine cycle, CO2 related cycle, organic Rankines you can see. There's an organic fluid has been used here. So ORC, okay, rocket related cycle, steam related various cycles, GT engine. These are detailed component related cycles now. So this is a closed loop, I think, a GT cycle. Okay, so these are various gas turbine cycle. Now I'll open one gas turbine which was with me. It's a simple one only. For example, I will have this. I'll just explain you, so you'll get the idea. Okay, so you will get the idea. Now I'll just explain all the things. Go to the if I go to the compressor, so it will get recorded in the video, so you will get the idea. So it's a compressor heat. This is the turbine. This is the GT gas turbine burner. Burner is I got from the burner area. You can see the first one. This is a generator. So all the component, this is a mechanical link. So I go to the compressor. Compressor, I say inlet properties I have specified. Mass flow rate is initial value I had given 10. Okay. Pressure I had given, so for example 10. Pressure I am seeing at atmospheric pressure 1. Temperature, for example, I am keeping 10. Output pressure I am getting a 6. Okay. And output temperature I am getting 100, for example, I am seeing. Power on shaft required here. Mechanical input this power. For example, something I can specify initial value as I am specifying as 100. Okay. I go to the gas turbine. In the gas turbine area, what I have done, this is the auxiliary component I got from this area. Okay, sir. This is the auxiliary, and I can connect this directly. These are all auxiliary. These three things are the auxiliary. 1, 2, 3. So this like ambient we are getting from that area. Okay, so now I go to the gas turbine. What I have done here, I have specified a custom fluid here. What are the custom fluids? Set custom fluids. I have specified two fluids. Flue gas, I selected carbon dioxide, water, and oxygen 4, and I given the name flue underscore gas. I selected here methane as one of the fluid also. Okay, so flue gas is very much important. I go to this compressor. Here is the flue. I have specified fluid, standard air only. Right now there is air. It will come from the compressor. Then it goes to the burner. Okay, their values and all those things. Now I go to the burner. A burner from link number 3. You can see from the top link I am getting a fuel. So these things you can specify from the top link number 3. Fluid media. I have selected here natural gas. I can specify methane also, but I have selected here natural gas. I am selected here natural gas. Then temperature of that natural gas is 20, and initial mass flow rate I have given an assumption value of 0.1, for example. 0.1. Now outlet link number 2, nothing has to be specified because this output which we have specified here, it will directly come here. Link number 4, basically this is the link 4. Those flue gases we have to specify here because combustion is done. This fluid which will be here, it will not be normal steam or normal fuel. It will be flue gases, the combination of gases which we are specified. So here after combustion, the flue gases, here a customer where those modified fluid which was there, custom fluid. So you can specify custom where of flue gases, variable type, because those flue gases are going to vary in the quantity. Okay, here the fluid media is the natural gas, but this is the custom where, and you have to select the flue gases, and its temperature you can specify something. I am saying here a 500 initial value. Okay, and heat loss also we are doing their heat loss. For example, I am initial saying 100. So this one is done. I'll come to the turbine. Turbine area is the internal efficiency. You can write down this pressure. You can specify here outlet area. The expansion we are getting here is a 1, and temperature we are specified is a 430. These units also you just keep in mind. Then power on shaft. Power on shaft you can specify here. For this compressor required is a turbine. What we are keeping is a minus 4683, and we want this much of power, electrical power, which we want to generate. This much of electrical power we want 1930. Okay, so this is the fixed quantity we have kept here. So keep it 1930. In gas turbine also, please make sure that this is the to condense this type of turbine. Okay, tutorial condenser type turbine. So there are 2-3 types, because we have to specify some different parameters. So here we have taken combustion efficiency and all those things. Sometimes you can get a air fuel ratio type of combustor or something. So that can also be specified, because here we don't require that right now. So we are taking that area. So I'm again repeating. So you go here. This is a design pressure type turbine, 0.85, 0.98. These are the initial value. These are the fixed value. You go to the gas turbine, gas burner. Here is the input link is a 3. 3 link is saying a fluid media, natural gas, mass flow rate is initial, temperature is fixed, and outlet link flue gases we have selected. Okay, the flue gases which we had modified here. Okay, you just go and see. We'll see the set custom fluid area, and flue gases is saying carbon dioxide 0.3, H2O, O2. So everything is done. I say calculate. Now calculation is done successfully. Calculation is done successfully. And if I go to the results, you will see that there are some other, the flue gases composition might have been changed. So here flue gases, previously we had given, you can see in natural gas we had selected, these are the composition of the elements in the natural gas. Methane or ethane, there is a methane addition has also been done. Okay, ethane was also there. So by automatic, by default, as per the temperature point of view, what are the flue gases we can get? These values has been specified. And there are molar masses has been, molar basis has been. Oxygen you will get 1. Nitrogen also you will get, because we hadn't specified nitrogen previously. But after doing a calculation by software, it has done. This what carbon dioxide we got and water we got as per the temperature which was there. So this is our gas turbine cycle also you can modify. Model in the simulation software. So I hope a lot of cycle I have been 2-3 cycle I have explained to you, which are relevant to the academics, like as for our UG purpose. Okay, now okay, so this was from my side. Any doubt, any questions, or should we conclude the session? Please give me the message. Okay. Is it okay? Some like the models, if you want to see, you can click on a load sample and you have a various list of the models. So from that area you can see a various number of cycle. I am closing this AxCYCLE now. Okay, is it okay? We will take one more session. Once I think you are very much busy in this area. We will take one more session when you're free and our engineers back to, once he joins the office, then we will take one more session. Till that time you can practice some example. If you face some problem, doubts, you can note down that, and we will clear it in that a doubt section, which we will take in upcoming times. Okay, some like 1 or 2 weeks after we'll try to do that. I hope it's okay from my side. Yes, thank you, Veer Singh sir. Okay, I'm concluding the session now. Thank you very much for joining this session. Thank you. I'm closing this. Everyone, I'll put that